Let's talk about Pythagorean theorem. Pythagorean theorem applies on right triangles. Right triangles are basically where the two legs forms a 90-degree angle, which can be represented through a square angle. Now, we will be following the Pythagorean formula, which would be a squared plus b squared is equals to c squared, where c would be the hypotenuse and the A and B values would be the legs. But keep in mind that whenever you have these A and B, this could be interchangeable. Basically, you put B on A on B. Doesn't really matter because you're adding them, not subtracting them. So whenever you get values from these legs, you could put it anywhere. Now, hypotenuse will be the longest leg on not the longest leg, but rather the longest line between these three lines of a triangle. Now, let's try for an example. Alright. Let's say 3 and 4. What would be the value of the C? Now, as I said before, you could put 3 and 4 anywhere on these values as long as it's on this part. Except for C though. C would be the on the right side or the opposite side of these two. So A, let's put A as 3 and B as 4. Now keep in mind that you have to put parentheses on these things because sometimes they're confusing, especially when you have negative numbers. Because you could have negative numbers depending on the quadrant that you're in. By quadrant, I mean on the graph scale. This is quadrant 1, this is quadrant 2, 3, and 4. And this have positive values. This has negative positive values. This has negative values, and this has negative and positive values. So yeah, so you could form triangle anywhere on those radians. So go back. 3 squared would be 9, plus 4 squared would be 16, and that would be the value of our c squared. That would be 25. But we're looking for the value of c, not c squared. So we have to square root this, guys, and you would end up with c, 5. So which means this would be 5. So where can we apply this stuff? Let's say you're on a place. You travel 5, you travel 4 kilometers west, and you travel 3 kilometers north. Your distance would be the amount of or how far you traveled, which would be 7 from point A to B or point A to B. It really depends on how you look at it. But overall, you would have 7 kilometers. If you want to take a shortcut from either of these points and go directly at this, you could have 5. You could travel 5 kilometers only. That's how you could get, or that's what basically one of the applications of hypotenuse. Now, let's try another example. Now, what if we try to find one that the hypotenuse is given, but one of the legs isn't? Can we still solve that? Of course. Let's give an example here. Oh, my bad. One example would be that. Let's say we are given 10 here, and this would be 6. So what it would be the value of b? So following this formula, we could assume that, not assume, but rather we could put these values. So 10 squared plus 6 squared and b squared. We need to separate this b squared because that would be the value that we want to have. So we have to transpose 6 squared on the other side of the equation. So we got b squared and 10 squared. Then since this is a positive value transposed to other side, then we could have 6 squared minus 6 squared or negative 6 squared. Then we square these guys up. That will be 100. My bad. And this will be 36. That would be b squared. Subtract those, we could have 54 b squared. No, 54 squared. What would be 54 squared? 54 square root is 3 over 3 square root of 6. So that will be the value of our b. So basically what happens is that if given the hypotenuse without b, where one of the legs aren't visible, you should try to transpose one value to the other. So that's basically what happens in Pythagorean theorem. Now let's try with triangles that are in quadrant 1. Let's try to solve. Let's say quadrant 3. So in quadrant 3, the x values and the y values there are both in negative because they are located where is the opposite sides. So let's try this one. This would be the hypotenuse, the c value, and this would be a. Let's say we have negative so a would be, let's say 6 squared, no, 6, and b would be 8. What would be the value of our hypotenuse? This would be negative because we're on quadrant 3. Because on normal quadrants, let's say quadrant 1, the positive side are on that way of the x value, and the y value heads up. That's where the positive values are. So let's try to solve this. C squared. Okay, this is why I told you to use parentheses, because you would be using wrong. Wait, you could be doing it wrong. Why? Because negative 6 squared is very different from negative 6 squared. Why? Because you're basically saying negative 36, and while the other one is just 36, because negative 6 times negative, both negatives multiply to each other, results to positive values. So yeah, so we could have 36, and for this one we have 64. So c squared would be 100. We have to square root both of these values. So we got 10. So which means this would be 10. The hypotenuse couldn't be a negative value, because for it to have a negative value, it would go to the opposite side of the initial starting point. For example, if this would be the starting point, it should go to the other end of the starting point. If it started from here and this would be the end point, then it would go here. So you cannot have a negative value on hypotenuse. So that is basically what hypotenuse, Pythagorean theorem, talks about. It talks about ratio and proportion of these right triangles. Because if one length, let's say, if one length increases, the distance would increase also. So there's certain ratios to that. And following the formula a squared plus b squared equals c squared tells the proportion that the values should have. So that's all for this video. I hope you enjoyed and learned a lot from this. Thank you.